Hey everyone, welcome back to our channel. Today we're diving into the fascinating world of quantum physics. It might sound complex, but we'll break it down step by step. We're talking about the fundamental building blocks of the universe, the essence of matter and energy at their smallest scales. Get ready to unlock the secrets of atoms, subatomic particles, and the perplexing laws that govern them. So, buckle up and prepare to have your minds blown wide open, because we're about to demystify quantum physics. Let's dive in. So what exactly is quantum physics? It's like a secret code book that unlocks the mysteries of the universe at the smallest imaginable level. We're talking about the realm of atoms and the even tinier particles that compose them, like electrons, protons, and neutrons. In our everyday world, things seem pretty straightforward. A ball thrown in the air follows a predictable path, and objects generally stay put unless acted upon by a force. But down in the quantum realm, the rules change entirely. Particles can be in multiple places at once, morph into waves, and even communicate instantaneously across vast distances. One of the most peculiar aspects is that observation itself can influence the outcome of an experiment. Imagine a game of cosmic hide-and-seek, where looking for the hidden object changes where it's hiding. That's quantum physics for you. This field emerged in the early 20th century, challenging everything scientists thought they knew. Giants like Einstein, Bohr, and Planck grappled with these strange ideas, leading to a revolution in our understanding of nature. Quantum physics underpins many technologies we rely on today, from lasers to modern computers and medical imaging devices. Fasten your seatbelts, everyone, because we're about to delve into wave-particle duality. This concept suggests that particles like electrons and photons can behave like both particles and waves. Imagine shining a flashlight through a narrow slit. You'd expect to see a single beam of light, right? But when scientists performed this experiment with electrons, they saw an interference pattern. It was as if each electron was passing through both slits simultaneously, creating a wave-like pattern. But here's where it gets even weirder. When they set up detectors to observe which slit each electron went through, the interference pattern vanished. The act of observation forced the electrons to choose a single path, acting like particles again. This phenomenon is a cornerstone of quantum physics. It suggests that observation can influence the state of quantum systems. Wave-particle duality challenges our classical intuitions and forces us to embrace the strange nature of the quantum realm. It underscores a fundamental principle. Particles exist in a superposition of states until measured. So get ready to embrace the wave-particle duality, a cosmic dance where particles and waves intertwine, blurring the lines of reality as we know it. Let's dive deeper into the mind-boggling world of quantum physics with the double-slit experiment. Picture this, a barrier with two slits and a beam of particles fired at it. Behind the barrier is a screen that detects where the particles land. If electrons behaved like tiny marbles, we'd see two distinct bands on the screen. But instead, we observe an interference pattern, as if the electrons were behaving like waves. It's as if each electron travels through both slits simultaneously, interfering with itself. Now, let's crank up the weirdness. Suppose we set up detectors to observe which slit each electron goes through. The interference pattern disappears. The act of observation forces them to behave like particles again. The double-slit experiment reveals a fundamental principle. Observation can influence the state of a quantum system. It suggests that the world at the quantum level exists in a superposition of states. The double-slit experiment is a powerful reminder that the universe is far stranger and more mysterious than our classical intuitions might suggest. Hold on tight, because we're about to explore quantum entanglement. This phenomenon, famously dubbed spooky action at a distance by Einstein, has puzzled physicists for nearly a century. Imagine two particles like electrons that are entangled, meaning their fates are intertwined no matter how far apart they may be. If we measure the state of one entangled particle, we instantly know the state of the other, even if they are light years away. It's as if they communicate instantaneously, violating our classical understanding of the speed of light. Einstein was deeply troubled by entanglement as it seemed to contradict his theory of special relativity. But numerous experiments have confirmed the reality of entanglement. It's as if the universe has an underlying interconnectedness that defies our classical intuitions. So how does entanglement work? The truth is, we don't fully understand it yet. Some physicists believe it suggests hidden variables, unknown factors that govern the behavior of entangled particles. Others speculate it points to a deeper level of reality. Regardless, quantum entanglement has profound implications for our understanding of the universe and the potential for groundbreaking technologies. It's already being explored for applications in quantum computing, quantum cryptography, and even teleportation. Hold on to your hats, science fans, because we're about to delve into Heisenberg's uncertainty principle. This principle, formulated by Werner Heisenberg in 1927, changed our understanding of the subatomic world. The uncertainty principle states that we can never simultaneously know both the exact position and the exact momentum of a particle with absolute certainty. It's like trying to nail down a shadow. The more precisely you try to pin down one aspect, the more elusive the other becomes. To see a tiny, fast-moving electron, we need to bounce light off of it. But even light carries momentum. So, when a photon of light hits the electron, it changes the electron's momentum, making it impossible to know its exact momentum at the moment we measure its position. Conversely, if we try to measure the electron's momentum with great precision, we inevitably make its position more uncertain. The uncertainty principle is not a limitation of our measuring instruments, it's a fundamental property of the universe itself. It tells us that there's an inherent limit to what we can know about the subatomic world. It also challenges our classical intuitions about causality and determinism. But far from being a limitation, the uncertainty principle is what makes the universe so interesting and diverse. It's the source of quantum fluctuations, tiny variations in energy that can give rise to particles and even entire universes. Get ready to be amazed because we're about to uncover the incredible ways quantum physics is shaping the future of technology. The transistors that power our smartphones, computers, and countless other devices rely on the principles of quantum mechanics. These tiny devices control the flow of electricity based on the behavior of electrons, which can act like both particles and waves. Moving on to lasers, those ubiquitous beams of light have revolutionized fields like telecommunications, medicine, and entertainment. Lasers rely on the quantum phenomenon of stimulated emission, where atoms emit photons of light in a coherent beam. Medical imaging techniques like MRI and PET scans rely on quantum mechanics to peer inside the human body. But the most exciting applications of quantum physics are yet to come. Scientists are developing quantum computers which have the potential to revolutionize fields like medicine, materials science, and artificial intelligence. Quantum computers utilize qubits which can exist in a superposition of states, allowing them to perform calculations exponentially faster than classical computers. Beyond quantum computers, scientists are exploring quantum cryptography, which uses quantum mechanics to create unhackable communication networks. The future of quantum technology is bright, and we're only just beginning to scratch the surface of its potential. As we continue to unravel the mysteries of the quantum world, we can expect to see even more mind-blowing applications emerge. And there you have it, a simple guide to the fascinating world of quantum physics. We've journeyed through wave-particle duality, entanglement, the uncertainty principle, and explored how these principles are shaping the future of technology. It's a field that continues to challenge our understanding of the universe and push the boundaries of human ingenuity. From the tiniest particles to the vast expanse of the cosmos, quantum physics reveals a universe far stranger and more wondrous than we could have ever imagined. If you enjoyed this video, give it a thumbs up, share it with your friends, and subscribe to our channel for more mind-expanding content. Until next time, keep questioning, keep exploring, and never stop marveling at the wonders of the quantum realm.